discussed combinations with example. Just go through previous lecture. Today I will discuss binomial coefficients and identities. Let's see first one example. Example 1, x plus y power 3. That we can write as x plus y multiplication x plus y multiplication x plus y. X plus y we are multiplying 3 times. First we will multiply these two. So x plus y multiplication x plus y. X into x, it's x square. X into y, xy. Then y into x, yx. Then y multiplied y square. This xy, yx both are same as multiplication is commutative. So we can write x square plus 2xy plus y square. This thing we need to again multiply with x plus y, as there are 3x plus y. We first multiply 2x plus y, then that result will multiply with another one. So x multiplied with all, it will be x cube plus 2x square y plus x y square. Then y multiplied with all, so it will be x square y plus 2x y square plus y cube. Now simplify this, it will be x cube plus 2x square y. Here is also 1 x square y. 3x square y plus xy square. Here is also another 2xy square. So it is 3xy square plus y cube. So after solve, we got x cube, 3x square y plus 3xy square plus y cube. So we went through all these steps to find this. If we have direct formula to find this, means any power we can find directly. X plus y power n. Let x and y be variable and let n be a positive integer. Then x plus y power n equals to summation of j equals to 0 to n nj. It is our binomial coefficient, or we can say combination of nj. That we can write as cnj or simply nj. Both are same. It is for combination of nj. This is in binomial coefficient format. Then x power n minus j, y power j. So first will be cn0, x power n, y power 0. So you don't need to write y. Then n1, x power n minus 1, y. Like this n minus 1, x, y power n minus 1. Then n, y power n. Here x power 0, so you don't need to write. So this is the formula for finding any power, like x plus y power 2, power 3, power 4, power 5, power 100. Any formula you can find by using this theorem. Let's see another example. Example 2. What is the expression of x plus y power 4? So x plus y power 4. Here n equals to 4. X plus y power 4, that we can write as summation of j equals to 0 to 4. Then 4j x power 4 minus j y j. 4 0 x power 4 4 1 x power 4 minus 1 3 y plus 4 2 x power 2 y power 2 plus 4 3 x power 1 y power 3 plus 4 4 x power 0 y power 4. So directly you can write y power 4. Now 4 0, that is 1. So 4 factorial divide 0 factorial multiplication 4 minus 0. So that is 4 factorial. These two will be cancelled. So it is 1. X power 4 plus 4 1 is 4. 4 factorial divide 1 factorial multiplication 4 minus 1 3 factorial. So 3 factorial will be cancelled. You will get 4. 4 x power 3 y plus 4 2 will be 6. 4 multiplication 3 divide 2. So it is 4 factorial divide 2 factorial multiplication 2 factorial. So this 4 factorial you can write 4 multiplied 3 multiplied 2 factorial. 2 factorial will be cancelled. This 2 4, it will be 2 multiplied 3 6. 6 into x square y square plus 4 3 again 4 x y cube plus 4 that is 1 y power 4. So we got x power 4 x cube y plus 6 x square y square plus 4 xy cube plus y power 4. So this is the formula for x plus y power 4. Next example 3. What is the coefficient of x power 12 y power 13 in the expression of x plus y power 25? X plus y power 25 you can write as summation of j equals to 0 to 25, then 25j, then x power 25 minus j y power j. Now for what value of j? This will be 12. So 25 minus 13 equals to 12. We need to find that coefficient of x power 12 y power 13. So when j equals to 13, 25, 13, then x power 25 minus 13, 12, y power 13. Okay. So we need to find this value, combination of 25, 13. So 25 factorial divided 13 factorial multiplication 12 factorial. So this 25 factorial you can write as 25 multiplication 24, 23, 22, 21, 20, 19, 18, 17, then multiplication 16, 15, 14, multiplication 13 factorial, divided 13 factorial, multiplication 12 factorial, that you can write as 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. After solve, you will get 5,200,300. Next example 4. What is the coefficient of x power 12 y power 13 in the expression of 2x minus 3y power 25? This question is similar to previous one. So 2x minus 3y power 25, that you can write as summation of j equals to 0 to 25, 25j, 2x power 25 minus j minus 3y power j. Here x power 12 y power 13, so j value is 13. Now for j 13, it will be 25 13, 2x power 12 minus 3y power 13. Now simplify this 2x power 12, that you can write as 2 power 12 multiplied x power 12, then this minus 3y power 13, that you can write as minus 3 power 13 y power 13. So coefficient of x power 12 y power 13 is 25 13 combination 2 power 12 minus 3 power 13. Let's see one corollary. Corollary 1. Let n be a non-negative integer, then summation of k equals to 0 to n and k equals to 2 power n. So when we'll consider x and y both 1, 1 plus 1 will be 2. So 1 plus 1 power n, this is our x, this is our y, that is equals to summation of k equals to 0 to n k, 1 power n minus k, 1 power k. 1 power anything, that is 1, here also 1. So it is equals to summation of k equals to 0 to n k. Let's see one example when n equals to 3. So summation of k equals to 0 to 3, 3k. Now this you can write as 3 0 plus 3 1 plus 3 2 plus 3 3. 3 0, that is 1, 3 1, 3, 3 2, 3, 3 3, 1. So now 1 plus 3 plus 3 plus 1, it's 8, and 8 you can write as 2 power 3. Next corollary 2. Let n be a positive integer, then sum of k equals to 0 to n minus 1 power k, nk equals to 0. Okay, so this 0 you can write as plus 1 minus 1. So this is 0, right? So here we'll consider x as plus 1, y as minus 1. Now in place of 0 you can write 1 plus minus 1 power n. So that equals to summation of k equals to 0 to n nk, 1 power n minus k minus 1 power k. So this 1 power n minus k, this is 1. So it will be summation of k equals to 0 to n nk minus 1 power k. Let's see through example. Suppose n equals to 2. Now summation of k equals to 0 to 2 minus 1 power 2 2k. So is this value equals to 0? Let me check. So minus 1 power 0 2 0 plus minus 1 power 1 2 1 plus minus 1 power 2 2 2, 2. Now minus 1 power 0, something power 0, it's 1. Then 2, 0, it is 1. So 1 plus minus 1 power 1, it is minus 1. 2, 1, it's 2. So minus 1 multiplied 2. Then minus 1 power 2, it's plus 1. 2, 2, it's 1. So 1 plus 1, 2. Then minus 1 multiplied 2, it's minus 2. 2 minus 2, it's 0. You take any n value, you'll get this result as 0. So summation of k equals to 0 to n minus 1 power k n k equals to 0. Next, corollary 3. Let n be a non-negative integer, then sum of k equals to 0 to n 2 power k n k equals to 3 power n. This 3 power n you can split as 1 plus 2 power n. Like here we consider x1, y1. Here we will consider x as 1, y as 2. So now x1, y2 in place of 3 we can write 1 plus 2 power n. So this is equals to summation of k equals to 0 to 1 n k 1 power n minus k 2 power k. This 1 power n minus k, it is 1. 1 power anything, it's 1. So we got summation of k equals to 0 to n n k 2 power k. This corollary is applicable for all number, like summation of k equals to 0 to n 3 power k n k, that is equals to 4 power n. This 4 you can consider as a 3 plus 1. Okay, even summation of k equals to 0 to n 9 power k n k, that is equals to 10 power n, right? Here whatever value you are taking, plus 1 will be there, right? If you are taking 2, here 3. If you are taking 3, here 4. If you are taking 9, here will be 10. Remember the theorem 1, that is the binomial theorem, and all these 3 corollaries. In next lecture, I will discuss Pascal identities. If this lecture is helpful for you, please like, share and subscribe. Thank you.